Hello everyone. So, today we will study transistor with external bias voltage. I told you that in case of transistor, basically we will focus a transistor as an amplifier. That means, a weak signal will be amplified by this kind of circuit. So, whenever we will consider a transistor in amplifier circuit, we have to connect the external bias voltage, external supply voltage with the transistor. Now, what kind of bias voltage should we give so that the circuit will behave like an transistor or like an amplifier rather. So, there are three type of bias voltage. Number 1 is forward forward, number 2 is reverse reverse, and number 3 is forward reverse. Number 3 is forward reverse bias voltage. Now, what do you mean by forward forward, reverse reverse and forward reverse bias voltage? Forward forward bias voltage means whenever we will consider this NPN transistor, this first PN junction diode will be connected in forward bias condition and the second one will be also connected in forward bias. That means, P type is connected in the positive of the battery and N is connected to the negative one. In the same way, reverse reverse bias means this N type will be connected with the positive and P type will be connected in the negative side. In the same way, forward reverse bias means first PN junction diode will be connected in the forward bias condition and the next PN junction diode will be connected in the reverse bias condition. That is why the name is forward forward, reverse reverse and forward reverse condition. Now, we have to see that among these three which one behaves like an amplifier circuit. That means, a weak signal will be amplified by this kind of circuit connection. So, consider the first one. So, here you know, if you forget about this part, that means the only PN junction diode is there with forward bias connection, then you know that in case of forward bias, when a PN junction diode is in forward bias, we will get a huge amount of current, right. So, the IC current, we will get the IC current, that the amount of the IC is large. Not only that, if you forget this N type semiconductor and only focus on this PN junction diode, then this PN junction diode is also connected in forward bias condition. So, obviously, we will get a huge amount of IE, that is emitter current from this PN junction diode. So, the amount of the current we are getting from this forward forward connection is huge, is large, but what is the significant thing? Is it behave like an amplifier? The answer is no. Why? Because see, if you consider suppose VBB is 0. So, if you consider VBB is 0, it will not affect the output of this circuit, that is IC. In the same way, if you consider that VCC is 0, that means if this forward bias voltage is 0, then the amount of the IE emitter current will not be affected. So, there is no interconnection, there is no connection in between output and input signal. So, we can write that the output current IC is not the function of the input current IE. So, there is no similarities, no connection between input and output current. So, if we give some input and output is something different, so how can it be an amplifier circuit, right. So, this one will not behave like an amplifier circuit. So, go for the next one, that is reverse reverse bias. So, reverse reverse bias, we know that in case of reverse bias, that means whenever suppose this PN junction diode is in reverse bias condition, then what will happen? Whenever a PN junction diode is in reverse bias, we will get very less amount of current and the current is called reverse saturation current, the amount is very less. So, the IC current, we will get this IC because of minority charge carrier, not majority charge carrier, and with respect to majority charge carrier, the number of minority charge carrier is very less. So, we will get very less amount of current. In the same way, if you consider this PN junction diode which is in reverse bias condition, then again the emitter current IE is very less. So, how can a weak signal will be amplified? Not only that, Here also the input and output, there is, in case of input and output, there is no similarities, no relation in between them. So, we cannot consider this kind of circuit also as an amplifier. So, go for the last one, that is the third one, that is forward reverse bias connection. Forward reverse bias connection, that means this p-n junction diode will behave, or this p-n junction diode is in forward bias condition and this p-n junction diode is in reverse bias condition. So, what we are expecting from this circuit? Basically, whenever this p-n junction diode is in forward bias, we can say we will get huge amount, large amount of emitter current. So, the current amount of IE will be large, and if you consider this p-n junction diode is in reverse bias, then we can expect that, obviously this one is in reverse bias condition, obviously we can expect the amount of IC will be very less, because the current from reverse bias condition, that is reverse saturation current, and that saturation current, we can calculate that saturation current only because of the minority charge carrier. What is the minority charge carrier for P? Minority charge carrier for P is electron. The amount of electron in P region will be very less. So, obviously, and in case of N region will be also less, very less. So, obviously, the current amount will be very less. So, we are expecting that we will get huge amount of IE and very less amount of IC. But now we have to see that what actually happens. Basically, whenever we will give external supply voltage VBB, then when this external supply voltage VBB dismiss the internal voltage, internal built-in potential voltage of this p-n junction diode, then the current there, when this VBB will dismiss the internal barrier of this p-n junction diode, then there will be no barrier. So, in case of, if you consider the silicon, then the barrier potential is 0.7. So, after giving 0.7 voltage, you can see that there will be no barrier, there will be no barrier. So, all the majority charge carrier, that is electron from N, will diffuse from N to P side, right. So, all the charge carrier, majority charge carrier of this N side will try to diffuse in P region. And actually what happened in case of the next p-n junction diode, in case of next p-n junction diode, whenever we are increasing this VCC, that is reverse bias voltage, then this barrier will be more and more, and due to this barrier, the minority charge carrier actually move, or minority charge carrier actually cross over this barrier and collected at the this collector region. So, what actually happened? 99% electron can cross this base region and come to this collector region. Why? Because in the previous case, the minority charge carrier of the P region was electron obviously, but the amount of electron was very less. But in this case, the amount is huge. Why? Because whenever we are giving the forward bias voltage, then after giving the forward bias voltage which is greater than 0.7 voltage, then there will be no barrier in case of first p-n junction diode. So, if there is no barrier, due to diffusion process, all the majority charge carrier, that is electron, will try to diffuse from N to P. So, now the concentration of electron is more in case of this P region. Very less amount of electron will recombine with the hole at P region, but 99% of electron will diffuse from this P type to this N type, that means from actually emitter to collector region. That is why we will get huge IC current, which is almost equals to the input current IE. So, this action is called transistor action. Why? I told you what do you mean by transistor action. Transistor action means we can pass a low signal, a weak signal from low resistivity region to high resistivity region. In this case also, electron are crossing from very low resistivity zone to high resistivity region. That is why this kind of circuit is called transistor action or transistor, right. So, here I told you that 99% electron actually come through this base region and collected at this collector. So, we can actually write IC, that is collector current, which is equals to IE plus IB, right. So, this is all about the forward reverse bias connection by which we can design a transistor circuit. Thank you so much.